Hi everyone. So this is the second installment of your algebra review. We're looking at chemical equations, which is really just more ratio work. Those of you doing chemistry, this is the stoichiometry part of that. So don't worry about it if you haven't done chemistry before. You don't need to. It's a simple idea. And I might actually encourage you to take chemistry because really a lot of the work that you do in chemistry is ratio work. So I should know, I was a chemistry major at university, and yeah, we did a lot of ratio work. And then the last part is abstract algebra, which is not really technically called abstract algebra. Abstract algebra is something much deeper. But for all intents and purposes for what we do, abstract algebra is really formula manipulation. So moving things around an equal sign. And so we'll start off with some chemical equations. It correlates to this particular booklet here, your Pre-Calculus 11 Algebra Review. So we'll start off with chemical equations. You'll see those, I think, on page 2. Yeah, page 2. So we'll start with some of those, and I'll just talk about some of those brief concepts. Alright, so I'll pause the video and restart up. Alright, everybody, so here we have a chemical equation. It outlines the burning of pentane, creating carbon dioxide and water. So here we have pentane, over here, pentane and oxygen burnt gives you carbon dioxide and water, H2O. So common combustion equation. Now you don't have to worry about memorizing chemical equations. This is in chemistry class. But what I want to explain to you is the relationship inside this recipe for burning pentane. So these numbers out front are the most important, right? The one that we have here, that's an 8, that's a 5, and that's a 6. And although we don't see it, there's a 1 right here, and I can show it. So one molecule of pentane plus 8 molecules of oxygen equals 5 molecules of carbon dioxide and 6 molecules of water. But the problem is, well, it's not really a problem, but the way that this is written, it describes individual molecules or groups of molecules, but we use something called a mole, M-O-L. It's the unit of measurement, M-O-L. It's kind of like grams, only not exactly. You can think of it like grams for now, and if you're taking chemistry, you know the difference. If you don't take chemistry, it doesn't matter. But it's kind of like the unit of measurement that you use. I don't want to spend a lot of time talking about what a mole is, but that's the unit of measurement. So 1 mole of pentane, 8 moles of oxygen, 5 moles of carbon dioxide, and 6 moles of water. And it's really a ratio. It's a ratio that tells you the combinations of each type as the recipe unfolds, because really it's just a recipe. So let's have a look at some of the types of questions you'll see in your booklet. Alright, so given the chemical equation up above, I say, well, if I have 10 moles of C5H12, which is pentane, how many moles of oxygen, O2, do I need, for the chemical reaction to take place? And I need it to be able to match up. So, this is a ratio up here of 1 to 8, and 5 to 6. So for every 1 pentane, I need 8 oxygens. So if I have 10 pentanes, how many oxygens do I need? Well, I just take this guy up here and times it by 10. So I got to times that guy by 10, and I need 80. So let's have a look and see how this plays out if we, do a proper job of this. Okay, so here's the T-chart, the T-charts. So you gotta start off with a ratio equation. When you're dealing with ratio work, you'll never go wrong if you start off with a ratio equation. Okay, so over here on the right-hand side, I've got C5H12 to O2, so pentane to oxygen is equal to pentane to oxygen. And remember from the last lesson, the letters that you use or whatever symbols you're using, they have to be in the same order. So if I got P and O first, then I need P and O second. It doesn't matter what order it is, but you got to make sure that the order is the same. And so now it's just about filling things in. Alright, so you get your first set of ratios from your chemical formula up here, right? Pentane and oxygen. 1 pentane, 8 oxygens. And that's exactly what I've got over here. 1 pentane to 8 oxygens. And then from the question, I say, well, what is it going to be if I have 10 pentanes, C5H12? You know, so how many X's am I going to get? So I fill it in over here, and I create the fractions, and now I have to solve for the fractions. Now X is on the bottom here, so don't forget you have to flip. So I'll solve it, and you can see how it plays out. Okay, so we flip the fraction, and then X is on top, so times by the divided by 10 on both sides, just regular work like we did last class. And so 8 times 10, that's 80. Now, you know, there's the math behind it. We already knew what the answer was. So let's have a look at a question that's a little bit more challenging, right? It's not so intuitive, and we'll have to actually do proper math to figure it out. Okay, so yeah, it'll still use the same equation, but I'll just change up what we're dealing with. Alright, so let's say I ask you to tell me how much carbon dioxide is produced in the following question. So if I say the reaction uses 96 moles of oxygen, O2, how much carbon dioxide is made on the other side of the equation? Right, so ratio equation, fill in the numbers, set up the fraction, solve the algebra. It's the same step all the way through. So there's the ratio equation right there on the board thing. So let's see how this plays out. Okay, so I filled in the numbers. The first side over here from the chemical equation up above, 8O2 and 5CO2, right? I get the 8 and then the 5 over there. That's where I get those guys from. And then from the question, I say, well, if I've used 96 moles, then how much O2 will I produce after the reaction is done? So there's the ratio equation, and now I solve it. Okay, so I convert to fractions. Yeah, the X is on the bottom, so I gotta flip it. No big deal, you've been doing this a bit now. And so now X is on the top, times both sides by 96. See what comes out on your calculator. It rhymes with 60. Okay, so yeah, 60. And you just go 96 times 5 divided by 8, or whatever. You can go 96 divided by 8. That's a little bit easier to think about it that way. 96 divided by 8 is 12, and then 12 times 5 is 60, but whatever. Right? Pop it off your calculator, and there's your answer. And so that page, that second page, is all this idea. It's setting up the ratio equation and going forward. And for most of it, you could probably do it in your head. There's the equations are fairly simple, but you know, some of them get a little bit harder. So, you know, when in doubt, you can just do it by your intuition and solve it and get it done. But if you ever come up against a problem that you're not quite sure, or you know, there's, you know, how does that get done? These numbers are weird-looking numbers, big numbers, small numbers, decimal numbers. You can always resort to this strategy, and you'll never go wrong. And so that's what I wanted to show you with that particular page, and get you to take those details sorted out. So I'm going to stop with the chemical stuff here, and then we're going to go on to the abstract algebra, just talk a little bit about that, and then that'll end our video. Alright, so remember, this isn't really abstract algebra. If you take abstract algebra at university, it's much more in depth. You wind up doing basically algebra with set theory. It's not pretty. But here what we're talking about is abstract algebra, basically moving variables around. So I give you a very simple equation, a plus b equals c, and I ask you to solve for a, which really means to isolate a on one side, move everything else to the other side. Now you've already done a ton of this already. You do it with slopes y equals mx plus b. There's lots of little abstract algebra you do all through the math course. So this is just the same idea, right? I have to isolate a, so that means I have to get b by to the other side. I have to cancel it out. And so it's algebra, right? What you do to one side, what you do to the other, you have to isolate, you have to cancel, you know, all those steps. So let's have a look, right? In order for me to get a by itself, I have to get rid of the b. So instead of canceling out a plus b, to cancel out a plus b, you minus b to both sides as usual. So minus b, those guys cancel. And I'm left with a is equal to c minus b. And this is your newly rearranged equation. Okay? That's what the job is. The problem comes when the questions get harder, and so we'll have a couple examples of those. You'll see how you do. You can have an idea about how to move this forward. Alright, so here's two very similar equations. A plus b times c equals d, question 1, and question 2 is ab plus c is equal to d. So in both cases we want to solve for a. You could solve for any letter, but we'll just solve for a to keep things consistent. So in the first case, a is by itself, like it's not by itself, but it doesn't have any coefficients or anything multiplied by it. So in order for me to isolate it, I just have to get rid of the b plus c as an entire entity. So I group them together and I subtract them from both sides, right? So minus bc to this side, bc, and minus bc to that side. Those cancel. I get a left over. And then, well, that part cancels, and I get d minus bc. Okay? So there's your solution solved for a. Right? A is not by itself, it's isolated, so it's solved for. And then you just get this, equation that's left over. And that's your answer. This style of question, this style of algebra is really, really good in science when you're dealing with lots of different numbers, say in a lab that you collect. You have an equation. Your equation may not be organized for the variable you're looking for. So instead of collecting all this data and doing algebra every single time, you do it once in the abstract to solve for the letter that you're looking for. Then you just plug them in, and it's just like plugging into a formula. Very straightforward, but it's it requires abstract work or non-concrete work. So with letters instead of numbers, and you just plug in your numbers afterwards. So you might have a long list of D, B's, and C's that you collected data from, and then you plug them in just to the formula. Boom, 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 boom. You get your answer for each of them, and that helps you speed up and make your life more efficient. So let's have a look at number 2. Okay, this here I've got two parts. I've got the C, right? And I've got the AB, and then the B is being multiplied by the A. So in order for me to isolate A, not only do I have to get rid of the B, but I also have to get rid of the C. And for many people, they make a mistake about which one to cancel out first. So here's how you figure it out. The best rule of thumb to use, and works like 97% of the times, pretty rare that it doesn't, is you start canceling out from the variable that's furthest away from the one you're trying to isolate. If you take that rule of thumb wherever you go, you'll have no problem dealing with these types of questions. So the first one we're going to want to cancel out is your C. So the opposite of plus C, of course, is minus C. And then after you've done that, then you'll have to cancel out your B. So A times B, so you got to divide by B. And let's see what the equation looks like. Okay, so I minus C to both sides, and so I'm left with AB, right? Because the C's cancel out here, right? The C's cancel out there, and the C's balances to the other side. So I'm just left with AB because the C's gone, and so I'm left with this equation right there. And now I still have to solve for A. So A times B, to get rid of times, you gotta divide. It's the usual stuff. So let's see what that looks like. Okay, so after I divided by B, I get A by itself, and then on the other side I got D minus C over B. I could, if I wanted to, write brackets around that. It's not wrong, it's just unnecessary. You can do that if you like. So just be careful about how those things play out. And really, this is the nature of that last page of the booklet. So if you can manage that, you'll be just fine. And next day we'll talk about our first new type of algebra.